Okay, so we've talked about optimizing the assets for delivery. Now we can move on to the metrics that we defined early on in this video series and talk about practices that improve those particular metrics. So first I'll talk about time to first byte. There are many factors that contribute to how quickly that first byte lands in the browser. First, latency is a big contributor. Connection speed works against latency and physical distance works against latency. Then, establishing a connection to the server can take some time, as we saw with that web page test waterfall. DNS resolution, establishing a connection, securing the connection, those all matter for that upfront connection delay. Then, the balance of where we do the dynamic work on a website impacts time to first byte too. Generally, dynamically served server-generated files are going to be a little slower than static files that the server can just turn around very quickly. So for latency, if you want to have a fast time to first byte, very little matters more than having things as static and as close to the end user as possible. And ideally, having as much real content in those initial bytes that arrive at the browser as well. For most sites, we can address latency and turnaround speed by using a CDN. So that's a content delivery network. Again, a CDN is just a series of computers distributed around the world that put your content closer in physical proximity to the people who are requesting them. So Cloudflare, Fastly, Akamai, Amazon CDN, Netlify, these are all content delivery networks that reduce latency through distribution of servers throughout the world. And it's not just about the first request time to first byte that matters here, but latency adds up throughout the waterfall with every request that's made. So it matters continuously throughout the loading process. So we want to use these tools to make time to first byte low for everyone. Another thing to look out for is if you're noticing a significant delay in the amount of time that's spent making a secure connection to your server, it's worth checking to make sure that you're running on the latest software for doing that. If you're using a host like Netlify or something modern like that, they're going to make this process really easy for you. They'll just automate the latest software installations. But if you are optimizing things on your own, there are some resources out there that you can check out. One that's really great is called istlsfastyet.com. Again, TLS is the technology for establishing a secure connection. This resource and a book that pairs with it is by Ilya Grigorik. So it's worth checking these out because it's possible you might need an update to the software that's running the secure connection. So after establishing a connection, you'll want to send, ideally, not a redirect response, if we can avoid it. We saw this earlier in that CNN waterfall. A redirect added a lot of time to the first view. We don't need to do that in all cases. So in cases where, say, you're redirecting a page just to add a trailing slash to the URL to make it prettier, we don't have to do that anymore. You can actually serve an HTML element that describes both of those pages as having the same content with a shared URL. So that way you can avoid redirecting and just serve the page at whatever the URL happens to be when the user first arrives. And that can save 1 or 2 seconds on the average web page waterfall. So redirects are harmful to user experience, and we don't necessarily have to do them anymore for SEO. So this is something to look out for. After latency, connecting, and redirects, you hit the server for a file to fetch. And that's when you start to consider the time that the server spends processing a response to turn around. This is a really nice graphic from an article that Adi Osmani wrote that describes a sort of spectrum of modern rendering approaches on the web. And they all have implications on time to first byte in different ways. On the way left, we have dynamic server rendering. And on the right, we have no server rendering at all, which can mean a faster turnaround. But it's not black and white. Different approaches on the spectrum have different advantages and drawbacks. Let's talk about each of these a little bit more. So first, on the left, we had the server rendering tools, and these are the sites that might use a database or server API calls and templating on the server side to compile a page for each request. Generally, dynamic rendering like this can be slower than serving a static page. There are nice mitigations that we can use to make this less of a problem. Caching plugins, or again, CDNs, anything that you can put between the dynamic generation of a page and the user so that the user is actually getting a recently generated static version of the page that they're looking for. That ends up allowing you to mimic a static server situation, even if your destination server happens to be dynamic. So worth remembering that this is a common place where delays occur. Then, moving a little further right, we have static site generators. These are really popular right now, and they generate some of the fastest sites on the web. I use them a lot. Filament Group's site is built on one of these tools. My own site is built on one of these tools. 11D or Jekyll, which has been around a lot longer, they make entirely static sites on the server. So you run a build task, and all of your templates get churned out into static HTML that can be sent directly to the browser. And the files that you generate can live on any static server or CDN and serve incredibly quickly. But these tools can be limiting, especially for big teams who need lots of user-facing features and highly dynamic user-driven content sites. But anyway, these kind of tools have really great time to first byte. Moving further right on the chart, we have sites that are data-driven and rendered on both the server and the client. We used to call this isometric JavaScript. And these are the big JavaScript framework-driven sites that we see today. This means that the server version could be pre-rendered or static, or perhaps rendered dynamically on the fly, and then rehydrated, as they call it, or in other words, made functional on the client side when the JavaScript arrives and binds behavior and data to the static markup. When done well, this can be a really great approach. But again, there's going to be that delay between when the page is delivered and when it's actually usable. And the more JavaScript that is involved in rehydrating the page that you already delivered, the bigger potential delay that users will experience. So this pattern, it's sort of where the future is right now, and people are figuring out how to do this in the most optimal way. Again, this pattern starts by serving something static, ideally, that's been generated beforehand. It can have a very good time to first byte. Moving further right, we have sites where the client experience is thick, as they say, but still has some pre-rendering. This is when you get initial bytes that are very fast, but they start to become less meaningful. One of the examples that you see often is known as a skeleton page that's served to the browser. So there's no actual content, but you get a sort of gray boxes mock-up of what the page will look like whenever it's popped. And a lot of sites use this technique. Facebook was using it for a while. You see this gray box loading approach on YouTube as well. The advantage over serving just a blank page before the JavaScript populates it is at least, the user can see that there's an indication of some sort of loading that's taking place. But of course, the downside here is the initial delivery of the page is useless until the JavaScript arrives and populates it. So it's a bit of an anti-pattern. It's too heavily client-focused and starts to work against the user's interests when it comes to loading a page very quickly. So the time to first byte here is very fast, but the first bytes that are arriving are not useful. And then further on the right, on the very far side, we have the full-on client-side rendering, which is basically that the user gets nothing until they get everything. And that's when the initial bytes are not useful at all. There isn't even an indication that the page is loading until it's just finally generated on the client side. And as an example of this, we saw the CNN site early on that just, ta-da, generated all at once. That's fully client-side rendering. Not ideal, even though it's a fast time to first byte. So it's good to understand that there are factors that can speed up your time to first byte while not necessarily helping your end game when it comes to performance. So to recap, you get a fast time to first byte by using a CDN. You want to make sure that your connection and your server software is up to date. You want to avoid redirects if at all possible. And we want to cut down on server work time by moving to static however we can.